Welcome to AccentUs. Today we'll be doing a new thing in lens, image formation by convex and concave lens. Let's start this chapter, but before that you should sit with your classmate because you have to draw a lot of diagrams. Before we start this chapter, at first we have to understand what is an image. We did this thing in lower classes in class 9 and all, but we have to understand what does image means. Okay, first of all, since we are dealing with lens, so let us think about two different lenses that we have in our syllabus, which is a convex lens and a concave lens. And from the definition of focus or the principal focus, we have this idea that if a parallel ray of light is incident on a convex lens, then it actually meet at a point on the principal axis, which is known as focus. Now, if you think in this particular phenomenon in a different way, we can imagine that a particular ray of light is actually meeting at a point on the principal axis, and it is then casting its own presence out there, and that is the image. Image is defined as the formation of another point or another presence of an object after refraction or reflection through lens or mirror or whatever it is, and if it actually meet at a point in real time, then that is called a real image, and if it appears to diverge from a point, that is called virtual image. Okay, that you can see here in case of a concave lens. When we send a parallel beam of light, it deviates away from the from the principal axis, which is quite usual because concave lens usually acts like a diverging lens, and this ray will diverge, and if we take the backward projection on the principal axis, we will get a point here, as you can see, which is commonly known as focus. This is also focus, and this point where the image will be formed, but it will be a virtual image because the person is standing here. Remember one thing, all of you, this is very important. This is a general thing that usually I've seen the students, they have a confusion, and that is in case of mirror. Okay, your real side is where you are standing. Okay, and usually we prefer to stand, and whatever in physics, we always keep the object to the left of the lens or mirror. But whatever it is, if it is a lens, the image, the real image will be formed to the side where the object is placed. But in case of lens, the real image will be formed. This is important, I repeat, the real image will be formed. If it is real, then it will be formed on the other side where you have kept the object. And for virtual image, it will be on the same side where you have kept the object. Okay, this is very interesting. For mirror, it is on the other side, but for the lens, for convex lens, the real side is this, and even for the concave lens, the real side is this. So it always forms a virtual image for the case of concave lens. Okay, now we'll understand a few of the diagrams, as you can see here. Okay, and we can see that we have the procedure to draw image through this lens, like convex lens or concave lens. You can see the first diagram where you can see the ray of light is passing through the optical center. We are considering thin lens, and it is passing through the optical center without any deviation for both the convex and concave lens. And for the second diagram, you can see the parallel beam of light parallel to the principal axis is passing through the focus for both the lens, actually is passing through the focus for convex, and it appears to pass in case of concave. And for the last diagram, what we can see that if any ray is incident from the focus and it is incident on the axis, on the vertical axis of the lens, then finally it goes parallel to the principal axis. So these are the three rays that we have to draw and that we have to use in order to produce the image formation by both these lenses, that is convex and concave. Okay, now let us see how we can draw the image formation by convex lens and concave lens. Here you can see the image formed by the convex lens. We are starting this topic now. the first diagram, you can see here that rays of light coming from infinity is ultimately converging at the focus of the convex lens. This is the way we can draw a diagram when we have a point object or very distant object. Now you can see how images are formed on the focal plane of the convex lens. When the object is at infinity, the usual convention is that the rays of light will converge to the focal plane of the convex lens. And here you can see that diagram where the image is formed at the focal plane of the convex lens. This is a usual description when we take photographs of a distant mountain. We usually see this kind of formation of image within the lens. Now we come to the second case. You can see the diagram here, and the object is placed beyond double focus, that is 2f, and when we are forming the image, it is in between the first and the second focus, and that is how the images are formed. And you can see the property of this particular image. It is diminished, erect, real, and it is formed in between 2f2 and f2, and the object is placed beyond the 2f1. This is the diagram and also the characteristics that I told you already. Now we have come to the case 3. This is the third diagram that we have to practice, and this is quite important because it gives you or gives us an idea how we can form the exact sized image out of an object, and then we have to place it at the double of the focus on the left hand side of the lens. As you can see here, AB is placed at 2f1 and the image will be formed at 2f2, that is the double the focus on the other side, that is the real side of the image. These all images are real, and the characteristics I specifically tell you. The characteristics are: image will be of the same size of the object, it will be inverted, real, and of equal size. These are the main thing widely used in telescope. You can find it in your textbook. Here comes the fourth one, the fourth case, where the object is placed in between the 2f1 and f1, in between the focus and double of the focus on the left hand side of the lens, and you can easily see here the image is formed beyond 2f2 on the other side, and that is the real side of the image. Okay, so here you can understand the characteristics is more you are closer to the lens, the image will go beyond the lens. As you can see in these, already you have seen 5 diagrams, and you can see this logic is being followed here, and the characteristics of this particular image will be, it will be inverted, it will be real, and it will be slightly magnified here. This you can see that A dash B dash is bit longer than the object AB. Okay, so this is the thing. Now we come to the fifth case where the object is at the focus of convex lens, and in this case, like, we have this idea that when rays are coming from infinity, that point of time we get the image formation at the focus or at the focal plane. Similarly, when we place an object at the focus, the image is formed at infinity. That means we won't be able to see any image if we place an object on the left hand side of a convex lens, and then we'll see the image which is actually not formed. So we call it is formed at infinity. Now you can see this is the most common use of convex lens is a magnifying glass, and this is the only case where convex lens forms virtual image. Right now, in all the 5 cases that we had already have done, and there all the images formed were real. But in this case, we are placing an object in between focus and the optical center of the convex lens, and finally the image is formed beyond the lens on the virtual side, and you can see it is on the same side that of the object, and in that side for image is called virtual side, I already told you. And you can see it is highly magnified, erect, virtual, and it is placed on the same side that of the object, and that is commonly used in magnifying glass. And this particular phenomenon is also used for constructing a compound microscope and all other microscope which we form, or in the tele lens that we use in camera. So this is a very interesting fact. You should practice this diagram. Now we can see the image formed by the concave lens. We know that concave lens usually forms virtual image, and it is on the same side of that of the object, and you can see here that the rays which is parallel to the principal axis and passing through the optical center, they finally meet at a point which is a virtual image. I already described this while telling you about the virtual image just a few minutes back in this particular lesson. So please do remember, and this diagram is also important because they ask you, this is the only diagram you have from concave lens in your syllabus, so this is important. Okay, so these are the diagrams that we have to practice a lot of times in order to draw it actually when it comes in boards or in your school exam, and these diagrams are very important. I repeat, you have to practice these diagrams a lot of times so that you draw this accurate, and you have to write the characteristics of the image thus formed for each of these cases. Okay, so please practice this. Now we'll do some examples. Let us do one example. As you can see, they have given us a few straight lines. They've given us one line which is marked as LL dash, and then the principal axis is marked, and there are certain points. We have an object AB. You can see here this AB is an object, and they are marked 2 points O and O dash. This is the lens. They have not mentioned about the nature of the lens. And now there are certain questions, okay, and we have to logically answer this question based on the properties that we have learned in this particular section that we are doing, even the things that we had learned in the previous section, that is lens part 1. So I'll suggest you once again, please watch that video part 1 in order to continue with part 2, and don't forget to keep your classwork in front. Alright, so this is the diagram. Now what are the questions they have asked? First of all, they have asked what is the nature of the lens LL dash. That is, they have asked, this is the first question, of course you can understand. And since you can see that there is a parallel beam of light from B, and it is incident on the vertical axis of the lens, and then it is having a tendency of divergence. So divergence, that in our scope of syllabus we know that divergence occurs for the case of concave lens. So the answer would be here, it is a concave lens. Don't forget that if they ask you the reason that why it is a concave lens, why you are telling it is a concave and it is not convex, because in science we should know what and why. So here when we are thinking, you have to write that since the ray is diverging after refraction, so obviously from the properties we know that this is a concave lens. Provided they have asked you, don't write all this if they don't ask you. If they are asking what is the type of lens, you just write concave. Okay, great. Now the second question they asked is obviously very important question, that what are the points OO dash suggests. O and O dash, you can see if I actually join this backward produce, then it is coming and making a point O. So obviously we can see that these are the principal, since O is the principal focus, then O dash will be the secondary focus. So in short, in one word, we can say this is principal foci, because it's plural. There are two foci, one at the principal focus, secondary focus, and together they are called principal foci. So these are the points, they are called the principal foci. Even if you write foci, that's enough. Okay. Now finally what they have asked is definitely to complete the ray diagram and finally mark the position of the image thus formed. And as you, by the time you have seen already the diagram, I have shown you that in concave lens we always have a virtual image. So the image will be formed this side, because this is the real side for the object, and this is the virtual side for image, and this is the real side for image, and this is the virtual side for object. Exactly, please remember, this is real side for object and virtual side for image, and this is real side for image and virtual side for object only for the lens. For mirror it is just opposite. Okay, fine. So now we have to complete the ray diagram. The next ray we have to complete is starting from B. We have to pass through X. And what is X? Oh, sorry, I forgot. The third question was what is X? You know already. I need not to tell you, and I need not to explain a lot of theories in order to that you'll say that this is optical center. I hope virtual image, it is dotted line. Okay, please, I repeat, don't forget this. All right, so this is the final form, and these are the 4 question marks. 4 marks were given in ICSE for this particular question, and we have solved this, so probably we'll be getting 4 marks out of all this. So this I wanted to explain you. And now this part of lens is complete. The next part will be, of course, doing numericals based on lens. Now your job is to complete the exercise, do whatever solve examples you have in your textbook, and don't forget a lot of questions are asked from this particular part, that is part 2 of lens, and this part is basically drawing diagrams and getting marks and knowing the facts and figures in exact. Like I told you, diverging ray means concave lens. Plain and simple logic. When you go to class 12, then you'll have lots of complexities in life and as well as in physics. So here it is very simple. Diverging ray, concave lens. Converging ray, convex lens. Okay, so you need not to think more than that. Anyways, so this is it, part 2 lens, and now it's your part. I'll send you other assignments in our WhatsApp AccentUs WhatsApp group. Okay, till then, I'm Arijit Ray telling you bye-bye, and don't forget that don't waste time, do practice things, because a lot of syllabus have already covered, not only in physics, in a lot of other subjects too, I guess, and you'll be having some kind of exams. I hope the schools will be taking for half yearlies and others. So I don't know the exact modes. Different schools are forming different modes. Okay, so you have very engaging time right now. All right, so till then, bye bye, stay safe and stay productive.